Now in complex analytic function, we'll be looking at the examples of a Cauchy's integral theorem and Cauchy's integral formula. Before that, please like, share and subscribe this particular channel and click on bell icon to get a new notification. Let us start now. Now we will the next question. The question is the value of integral of closed curve minus 3z plus 4 by z square plus 4z plus 5dz, where c is in a circle for mod z is equal to 1 they equal, right? So they are asking for the value of integral of closed curve minus 3z plus 4 by z square plus 4z plus 5 dz is equal to how much? We have to find it. First we have to find the poles. Okay, poles of z square plus 4z plus 5. For this one we know the formula is nothing but minus b plus or minus root of b square minus 4ac by 2e. So we get minus 4 plus or minus root of, it becomes 16 minus 4 5 are 20 by 2, right, which is equal to get minus 2 plus or minus, it becomes root minus 1, which is equal to minus 2 plus or minus I, right. Now we have two poles, minus 2 plus I and minus 2 minus I. Now we'll be seeing which of them would be falling in the curve mod z is equal to 1. If you consider a graph here, this one is real part of an z, the imaginary part of an z, right. Now if you draw a circle such that it is centered origin and radius is nothing but 1, right. Now to find where the point minus 2 plus I and minus 2 minus I comes, right. So for this one, first we're defining the modulus of minus 2 plus I or minus 2 minus I. Then we get nothing but under root of an 4 plus 1, 2 square plus 1 square, which is equal to root 5, which is equal to, we get 2.23, right. So it will be somewhere here 2.23 and negative wall will be coming minus 2.23 here, right. So it will be somewhere outside the circle. So if it is outside the circle, okay, what you do is nothing but use a Cauchy's integral theorem. Then we know that integral or closed curve f of z dz is equal to nothing but 0 is Cauchy's integral theorem. So it becomes nothing but 0. Now come to the next question. The question is the value of integral of closed curve c, right, sin pi z square plus cos pi z square by z minus 1 to z minus 2 dz, where c is nothing but a circle for mod z is equal to 3 z. So we have to find the integration over closed curve. First we'll be finding the poles, right. You can see that z is equal to 1 comma 2 on the simple poles, right, as we have an order of it's nothing but 1. Now we'll be checking which of the two would be inside the circle mod z is equal to 3 or not. If you consider a graph here, the real part of an z, the imaginary part of an z, the given mod z is equal to 3, so it is centered at an origin and the circle is radius of an 3. So 1 and 2 would be inside the circle. As we know, 1 is less than 3 and 2 is less than 3. So it is inside the circle. So we have to find the integration for both of them. For this one, what you do is nothing but first split 1 by z minus 1 into z minus 2. Split it to a by z minus 1 plus b by z minus 2. Okay. Now if you consider z is equal to 1, then you get a into 1 minus 2 is equal to 1. Then we get a is equal to minus 1. And when z is equal to 2, we get b into 2 minus 1 is equal to 1, which implies b is equal to 1, right? So just substitute here. It's nothing but you get as minus 1 by z minus 1 plus 1 by z minus 2, right? But here we have sign and constants also. So multiply the whole thing with an sine pi z square plus cos pi z square. And you have to find the integral for closed curve C, right? So for this one, when you're using the cos integral formula, we know it, right? This is a formula. Just applying for both of them. Then we get the first one. We get as 2 pi I by n. N is nothing but here the power of 1. So here n is equal to nothing but 0. And e value is nothing but 1, right? And here also n is equal to 0 and e is equal to 2 here. So it becomes 0 factorial into minus 1 into f n of e. Means we are not doing any differentiation. N is 0. So no need of any differentiation. Becomes minus 1 into sine pi z square plus cos pi z square. You have to consider z is equal to nothing but 1 plus get 2 pi I by 0 factorial, the second term, okay, into it becomes sine pi z square plus cos pi z square. You can consider z is equal to 2. Just substitute it. We get nothing but minus 2 pi I into, now z is equal to 1. So substitute here. Z square is also 1. So it becomes sine pi plus cos pi plus the other term is 2 pi I into, we know 0 factorial is nothing but 1, right? Now z is equal to, then z square is nothing but 4. So it becomes sine 4 pi plus cos 4 pi, right? Now sine pi is 0, cos pi is minus 1, sine 4 pi is 0, and cos 4 pi is 1. So it becomes nothing but minus minus, it becomes plus 2 pi I plus 2 pi I, which is equal to 4 pi I. So answer is nothing but 4 pi I. Now come next question. The question is the integral over closed curve z plus 4 by z plus 1 z minus 2 dz along on the contour. Mod of z minus 2 plus I is equal to 2. Oriented anticlockwise is equal to. So they are asking for the value of integral or closed curve z plus 4 by z plus 1 into z minus 2 dz. Right. Now we have to use a general formula. Cos is integral formula. We know the formula is nothing but this one. And you have to check whether A is inside the circle or not. Right. Now what you do is nothing but find the poles of this one. We get z is equal to minus 1 and z is equal to 2. Yeah, two poles. And which of them would be lying inside the contour? Mod of z minus 2 plus I is equal to 2. Right. If you consider graph here. Now in this particular graph, we know this is a real part of an z. This is an imaginary part of an z. If you consider a point here as an 2 plus I. Okay. Now draw in a contour. Okay. Now we'll be checking which of the points will be inside the circle. What we do is nothing but first substitute z is equal to minus 1 and find the mod of it. It becomes mod of minus 1, minus 2, minus I. Should be less than or equal to 2. Right. As we know that if the radius is nothing but 2 given, right? And if it is less than or equal to 2, we can say that it is inside the circle or boundary of a circle, right? So defining the value of it becomes mod of minus 3 minus I should be less than or equal to 2, which implies it becomes nothing but root of 9 plus 1 should be less than equal to, which is equal to root 10. Root 10 is not less than equal to 2. It does not satisfy. So minus 1 would be coming outside the circle, right? Now if you consider z is equal to, we're checking if it is inside the circle or not. It becomes mod of 2 minus 2 minus I should be less than equal to 2, which implies it becomes mod of minus I should be less than equal to 2. So it becomes 1 is less than equal to 2. It got satisfied. So we can say that 2 is inside the circle. So we can write this particular function as nothing but integral of closed curve z plus 4 by z plus 1 into 1 by z minus 2, right? Then we get this particular term as f of z, and z minus 2 is nothing but z minus a whole power n plus 1. So here we get n is equal to nothing but n is equal to 0, right? And a is equal to nothing but 2, we got it. So just substitute here, we get as nothing but 2 pi I by 0 factorial into f of z is given as z plus 4 by z plus 1 for z is equal to 2, right? So which is equal to 0 factor is nothing but 1. It becomes 2 pi I into 2 plus 4 divided by 2 plus 1, which is equal to 2 pi I into 6 by 3. One side goes for 2 sides. This is equal to 4 pi I. So answer is nothing but 4 pi I. Don't get confused. It is given as oriented anti-clockwise. Anti-clockwise means it is moving in this particular direction, right? When it is a clockwise direction, we get a negative sign. Okay, remember this one. For an anti-clock, okay, the value would be nothing but positive. For the clock, you have to consider the values and negative values. Okay, the same formula for the clock, we get a minus sign. For anti-clock, we get a plus sign. Okay.